Hello, I'm Steve Spencer, and today I'm going to talk to you about Azure Machine Learning Studio. So, I'm a developer, so I'm going to approach this from a developer's point of view. So, if you're a sort of an analyst or a data scientist, you should still get something out of this because I'll be able to show you the tools, but the details of algorithms that you probably know a bit more about it than I do. So, Machine Learning Studio allows you to create experiments and then build predictive models. So the first thing you need to do is actually get some data to sort of build this model and to test with. So there's this data sets tab. I've already uploaded one, so this is a free one you can download from the Microsoft sites, but it's really easy to upload your own. So you can go in, click from file, and upload. You can have the different sort of formats of file that you want to upload. So if I wanted to actually do something and create this experiment, I need to create a new one, and there's a whole load of templates you can pick. But we'll start with a blank one. And when the blank one starts, it gives you the template. Gives you a workspace where you can drag things on. So on the left here is a whole set of connect of components you can drag on and do things. So we've got my data set will be in here under my data sets, and I can drag that on fairly easily. And it just drops. Could drop that anywhere. So what we're going to do is click on here and look at the data. So this will take a sample of the data set and allow us to view it. So this is US employees, and there's a whole set of data points for that person, and there's a value at the end which determines whether they're earning more or less than 50,000 US dollars. So we're going to use this column as the one that we want to predict, um, and by looking at the data set, we can actually work out what that would whether that would be 50k or less or more. So that's why we need to build the model. So the first thing we need to do is we have that data set, and we actually a lot of the time the data that you get is not in the format that you want, so you need to do something with it. So we can manipulate that data. So there's a whole load of components you can add. So what I'm going to do is clean missing data. And you can see there's these connection points on, and they do different things. So if I want to connect these two together, I can take that data set. See, it's gone green. It allows me to connect to that point. So connect that up, and what we need to do is configure it. So on over here, we can pick whether we want to select specific columns. Maybe we know that there's missing data in the salary column or whatever, but I'm just going to pick them all, and I'm going to substitute. So all I'm going to do for this is I'm going to put some values in that we can go and see fairly easily when we look at the data later on. So at this point here, um, we have the data that's clean. So it's come in from here. We've gone through and added those extra fields that are missing. And now what we need to do is actually, for machine learning to work, we need to do some training of that data. So what we need to do is take that data set we have and split it. So we'll use a portion of that data for training, and we'll use a portion of that data for testing, for evaluating later. So what this component does is it randomly picks data from the output of here, so that clean data, and it's picked 50%, so it'll take half of them and put half of them down dataset 1 and half of them down dataset 2. So we can change that if we want. So let's say we want to take 75% of the data um, for training, and then we use 25 for checking. So that means we've got the 75% going down this side and the 25% going down that side. So at this point here, we're now ready to start building the model. So what we actually need to do is pick an algorithm to use. So this is where if you're a data scientist or an analyst or mathematician, you'll know a lot more information than I do. So the Machine Learning Studio has 4 different types of model that we can use, and the first one is what's called anomaly detection. So I guess the thing that the most familiar with this would be sort of your credit card transaction for fraud. So when you sign up, when you make a payment and on some dodgy website, for example, you might get a call from your bank saying, is this a valid transaction or not? Or it may be somebody actually trying to steal money from you, and then you can tell them that it was fraud. So they've got these algorithms that are looking at anomalous payments and trying to work out whether that's real or not. Then we've got classification. So classification is if you've got a set of buckets of data you want to put them into. So um, it will say whether it's of type A, type B, or type C. And an example of that might be you're doing some maintenance on a car and you want to know whether the tyres are going to wear out in the next 1,000 miles, and that's a yes no. So that's a two-class classifier. Um, you could have multi-class um, and a whole load of others. And we're going to use one of these because we actually want to know whether they're greater than or less than 50k. So again, that's a two-class, but I'll come back to that. So the last two are clustering and regression. So clustering is about looking at patterns of data and seeing where they're sort of grouped. And regression is if you want to predict a value. So for example, what's my profit going to be in 6 months, a year's time? That's an actual value. So it's different to classification. Classification is a set of fixed types, whereas regression is it could be any value between whatever range you set. So let's go and pick one of these. And again, I'm not the expert of what these algorithms mean. So I'll pick one and drag that on. So again, um, we've got an output, but we've also got a whole load of parameters you can change. I'm not going to change them because I don't know enough. So this is where you probably need some help from a data scientist who understands this and works out what they want. But what we do need to do is initialize our um, is to start training. So what we need to do is pick train, and what we can see here, this has got two inputs. So we can take the data, and you notice now that these are red, so it won't let me connect it to that one because that's for the data, and so it'll only let me connect it to the model, the untrained model section. So do that. I can drag in our data set as well. So that's the 75% of the data that we want to train the model with, and push it through there. So we're ready to train, but we've noticed we've got an error. So what we've not told the trainer to do is what are we actually trying to predict. So we can pick the columns that we want to predict, or the column we want to predict on. And actually, in our data set, we wanted income. So you should be able to type, and it will start picking the values we want. So it's saying we're going to look at that income column, and all the ones we know the answer for, which we've already put in, it will use for training. And then when we get to doing testing, it will take that other quarter of the data and actually predict based on the model that's trained, and we'll be able to see how accurate or not the algorithm is. So with our model that's trained, we now need to score. So we'll take the data from the model that we've trained, and again, this has got a red and a green, so it'll only allow me to push that data through there. But I also then need to take that 25% of the data that we haven't used yet, and we'll push that in. Oops, push that in to score. So what this will do is it will take the model that we've trained, it will take that 25% of the data, run it through the algorithm, use the predictive answer that it's got, and we'll be able to see how accurate it was because we'll be able to see the actual answer and the predicted value. And the final thing we actually need to do is just do an evaluation. So we'll pick evaluate and drag that into there. So I'll just make that so we can see it. So what we have now is we have our model that's built. When we can drag these around if we want, sort of tidy them up, make the line straight if that's what you want to do. But what we need to do now is actually run this. So all we've done is built it. It doesn't actually do anything at the moment. So there's a run button down here, and what that run does is it will initialize everything. We'll take the data set. We'll clean it, so it's put those W's in. It's now going to split the data, so it'll split it down randomly. It'll take 75% of them for training, 25% for scoring. It's taking that 75% now, and it's running it with this algorithm. and it's training it. So it's looking at that income column and working out a model based on that. And now it's taking the 25% of the data that we haven't used yet, and it's going to run the model through based upon what it's learned. And then we've got an evaluation, and that's complete. So what we can do is on each one of these connectors, you can do visualize like we did before. So what we should see on this one is we should see the missing data, any data that somewhere along the line there ought to be. So we have one there. So it's populated fields it doesn't know about with those 4Ws. We can look at a graph. This will produce a graph. So this will produce, and what this is actually saying is I guess it's not too bad at predicting at this side, sort of down, and at this point onwards, but these bits in the middle, you need to sort of make a judgment call of whether you want to trust the values in this range. Ideally, if that graph was sort of steeper and more towards the axis, then you would be able to use these have a higher confidence that the prediction is better or not. We can look at what's actually been scored as well. So if we go into visualize on the score, we'll be able to see the data that we've got. So this is the same data with those values in, and you can see that this is the actual value. This is what it's predicted, and then you've got a probability. So anything less than 0.5, it will take us in the less than 50k bracket. And anything more than 5, it will put in the greater than 50k bracket. And you can see this one here is incorrect because it's predicted it as greater than 50k. It was actually less than, but it's fairly confident. It's like 80%, so that's at the high end. Whereas like this one, for example, is really confident because it's like 0.02, so that's 2%, 3%. That it is less than 50k. So if you get into a range of, I guess 80%, so 17%, 16% of uncertainty of it being greater than 50k. We got any others down here? So we have one here. So that this one is predicted at less than what is actually greater than, and that's so I would say that 30% is probably, we're getting to that point now where you're not that confident. So you can use the answer plus the probability to determine whether you want to trust that answer. So for example, if we were using this as a whether we're going to lend somebody some money, for example, so some sort of automated underwriting service, we would have a percentage value under which we would be happy that we could accept them. We'd have a percentage value above which we'd be happy to reject them. But then we'd have a band in the middle where we wouldn't really be sure. So let's say anything less than 25% we'd be happy. Anything above 75% we'd be happy. But those in the middle we would be unsure. So maybe we'd need to do something else with that data. Maybe that would go through some other algorithm or some manual process or whatever. But you need to look at the two values together just to sort of give you some confidence of what the answer actually is. And as you've seen, we've got some that are wrong. So it is a prediction. So you're not always right. So it's one of those things. So what we can do though is going forward is we can take the data that once if this was real data and we didn't know this answer, as soon as we did know the answer, we could feed that back in and retrain and hopefully build a better model going forwards. So what that's given us now is a nice model. We can run it with data that we have, and actually we could stop there, just use it. We could put our data set in, run it through, and be quite happy. But what's really useful is to then take that data and push, or that model, and push it out as a web service, so we can then build this into an application. And actually, this is really easy. So you can click on the predictive web service button, and what you'll see is this will rearrange and create the web service for us. And what you might not have noticed is it's actually created two. So this is the original experiment here, and we've got a predictive experiment. So this predictive one is basically had the web service bits put on, and it's transformed our training experiment into something that we can actually use and deploy. And what we also have to do with this one is run it again. So exactly the same way as we did with the training, we need to run this through. So this is just initializing everything, pulling the data through, um, and it will, once it's done, we can then deploy it. So it's just scoring this. So that's complete. So there's a button to deploy, and we can click that. Um, what this will do now is it'll deploy it to an environment, it's a web service, and that's done. So what you can see is we've got a key, so we can use our API key. We can test it, but actually there's a new web service experience. So we can click on that, which is a better interface, a lot more a lot more information in there. When it loads, so it's loaded. What we can look at is we could test this, for example. So it's generated a form. So this is all the data that you saw in the data set. I could populate those fields and hit the test button. It would give me a prediction. We could do a batch mode, so that allows me to effectively put a CSV file in, upload it, or pull it from a storage account. But what we want to actually do is consume this in some code. So it gives me a URL, it gives me a key. What it also gives me is some code. So I can take this code, and this is configured up. I would push my API key in, so copy that in there, copy the URL, and we could run this code as is, and it would be fine. We can also do some configuring if we want. We can look at the Swagger. We can look at the dashboard of what requests we've had. So that's web services. What we also want to do is we might actually want to upgrade this. So what we can do is go back in to our experiments, pick the one we've just created, and go back to the training one. So what we need to do is pretty much go through a similar process. So this is what we built originally. Let's just do something fairly straightforward so that it's so all I'm going to do is change that value. We can then have to run that again. So again, this is going to go through, initialize the data, initialize the algorithm, get the data, it's training, it's split, it's training. It's then going to score the model and do that evaluation when that's done. So that's done the experiment. We now need to do it, and this time it's changed to update. So we can update the predictive experiment, so that will go and change, add that extra clean data to the experiment. We have to run it exactly the same as process as we did before. So this is initializing everything and training the web service. And when that's complete, we should be able to deploy that. So I can hit deploy, and what this will do this time is it's actually asking me if I want to overwrite. So it's not creating a new one, it's going to overwrite. So again, I can deploy that. And it'll have the same URL, the same key, and my new application will run, and it'll call a web service, and I'll get a different, I'll get the new model used. So that's it for Azure Machine Learning Studio. So hopefully I've given you enough of a insight into what you can do with this. I've shown this tool to a number of my colleagues who are data scientists, and they've different people have use it different ways. So one of the guys basically built a really complex model, which he said would have taken him probably 2 to 3 weeks to do. He did it in a couple of hours, and he got really good results. So it's actually saving some time. So that was pretty good. So Azure Machine Learning Studio has been really useful. It saves some time. It allows us to build models that we can then wire into web services and wire into applications. So it means that we actually getting access to some of these models that we maybe not have had access to in the past. So I hope you find this useful. Thanks for watching. I'm Steve Spencer, and I'll be doing more videos on similar topics in the future. Thanks a lot.